I'm Adam from RFOXiA from our real lab. Today we're asking, why does your GPS know where you are but not where you are right now? Let's talk about what a fixed rate actually means, because most people building with GPS modules have never had to think about it until the moment they absolutely had to. A GPS fixed rate is how many times per second the module calculates and outputs a new position. Standard consumer GNSS chips, the kind you find in development boards and budget tracking modules, operate at 1 Hz. 1 position update per second. That sounds fine if you're walking. It is not fine if you're flying. A drone cruising at 60 kilometers per hour covers 16.7 meters in 1 second, which means between each GPS update, your autopilot is flying on dead reckoning. It is extrapolating. It is guessing with reasonable confidence where it thinks the aircraft is based on the last known position. For 1 full second, every second, your drone does not know where it is, it knows where it was. At 1 Hz, that gap is 16 meters. At 100 kilometers per h, it becomes 27 meters. This is not a theoretical concern. This is the actual math behind why racing drones lose position lock in tight courses, why delivery drones struggle with precision landing, and why autonomous systems have to build elaborate sensor fusion pipelines just to compensate for a fundamental limitation in their GNSS update rate. The problem is not satellite coverage, the problem is time. Now let's talk about accuracy, because fixed rate and accuracy are related but distinct. They are often confused. Accuracy is the radius within which your reported position is likely to be correct. Standard consumer GPS achieves somewhere between 3 and 10 meters under good conditions. In urban environments with multipath interference, signals bouncing off buildings before reaching the antenna, accuracy degrades further. 10 meters becomes 15, 15 becomes 25, your position bubble grows. For a phone navigating city streets, a 5-meter error is invisible. For a drone attempting a precision landing on a 60-centimeter pad, 5 meters means you missed by the length of a car. Here is where the two problems compound each other. Low fixed rate means your position data is already stale by the time the autopilot reads it. Low accuracy means the stale data was not even precisely correct to begin with. You are flying on old information that was approximate when it was new. The conventional solution to this has been RTK, real-time kinematic correction. RTK uses a ground-based reference station to broadcast correction signals to the airborne receiver, narrowing accuracy to centimeter level. It works. It also requires a base station, a radio link, a license in some jurisdictions, and a setup procedure that adds cost, complexity, and single points of failure. RTK is the right answer when you need centimeter precision. It is expensive infrastructure for applications that need sub-2 meter precision at high update rates. What most drone builders actually need is a module that updates fast enough to track a moving platform accurately, with position accuracy tight enough that landing, tracking, and waypoint navigation work reliably without additional correction infrastructure. The MultiNav Pro Plus was designed around that specific requirement. The fixed rate is 18 Hz, that is 18 position updates per second. At 60 kilometers per hour, the gap between updates is now 0.93 meters, less than 1 meter of uncertainty rather than 16. At 100 kilometers per h, the gap is 1.5 meters. The autopilot is working with data that is 55 milliseconds old instead of 1000 milliseconds old. That difference changes what the control loop can do. The accuracy figure is 1.5 meters. That is the CEP, circular error probable, under nominal open sky conditions using concurrent multi-constellation reception. This module locks onto GPS, GLONASS, Galileo, and Beidou simultaneously. More satellites in view means better geometry, which means tighter position estimates, which means that 1.5 meter figure holds under conditions where a single constellation module would be drifting to 4 or 5 meters. That's the physics of why fixed rate and accuracy determine whether your system actually knows where it is. Now let me show you the hardware that solves it. This is the MultiNav Pro Plus, a 26 by 22 mm module built on the U-Block's MIAM10Q, one of the most capable GNSS chips available at this form factor. It runs GPS, Galileo, GLONASS, and Beidou concurrently, which is what gives it the satellite geometry needed to hold 1.5 meter accuracy consistently across environments. The headline numbers are 1.5 meter accuracy and an 18 Hz fixed rate. In practical terms, that means at 60 kilometers per hour, the gap between position updates is under 1 meter instead of 16. The first fixed time is 1 second from cold start. For dynamic platforms, these three figures together change what your control loop can actually do. power draw sits at 25 to 30 milliamps during active tracking. For a module running 4 constellations at 18 Hz, that is a well-optimized figure. The 26 by 22 mm footprint fits into tight integrations without rerouting your board layout. Small and efficient enough that it disappears into the design. The module supports both UART and I2C interfaces and operates at 1.8 volts or 3.3 volts. That voltage range means it connects cleanly to modern microcontrollers without level shifting in most configurations. Standard NMEA protocol on both interfaces, nothing proprietary, no adapter required between the module and your processing stack. The driver library is fully open source, written in C, and includes complete NMEA protocol handling, imported directly into Arduino IDE or any toolchain that accepts a C library. You are not reverse engineering a closed protocol or waiting on vendor support. The library is there, it is documented, and it works on first connection. uCenter is the configuration and evaluation software provided by uBlocks. It visualizes satellite signal strength per constellation, logs position data, and lets you adjust output rate and message configuration through a graphical interface. Useful for validating performance in the field before integrating into a production firmware build. The applications are what you would expect from a module at these specifications: drone autopilots, precision agriculture, asset tracking, wearables, research platforms, robotics, and any IoT deployment where a position bubble of 5 to 10 meters is the difference between a working system and one that merely appears to work. First valid position in 1 second. In field deployment, that means you do not wait, you power the system, you get a position and you fly. The combination of fast first fix, 18 Hz output, 1.5 meter accuracy, and 4 constellation support closes almost every gap that makes standard GPS modules unsuitable for serious applications. The MultiNav Pro Plus gives you location data so precise and so fast that your drone, robot, or tracker knows exactly where it is before you even finish asking.